Okay. You're watching a one-liner be made. It's October 29th, 2024. Oh boy. Hopefully it won't be too long of one. Okay, minimum number of removals to make a mountain array. Okay. What happens if it's purely ascending or descending? Does that work? Oh, we just can't have, okay. So we can do this in O of n squared if we need to, but I kind of feel like maybe you can do it in O of n. This feels like a monotonic stack thing or something. The fact that I don't immediately remember what to do means that there's still something to be gained from this. Nums at I goes up to 10 to the 9th, but that's not as bad as you might think if you tried to use the value. If you had like DFS of I and X, and I might just be lazy today, I might just do like something recursive, and if I get like an O of n squared solution and there's something better, like I don't care. Okay, you have something like this, and you're saying at a given index with a current value. Seems pretty bad because your state space could go up to 1,000 times 10 to the 9th is 10 to the 12th, but there's only 1,000 distinct things X could be because there's only 1,000 elements, so you're kind of good there. And then the other thing you would kind of want is like, are you currently increasing or decreasing? Does it have to be purely increasing and decreasing? Yeah, it can't just be like non-decreasing and then non-increasing. It has to be like less than, greater than. Okay, return DFS of something, but I'm really going to say res equals DFS of something, dfs.cache clear, return res. That way you're like clearing the cache every time and it's not going to get like an MLE or anything. So maybe I'll just say inc, something like that for now. And then this is going to be a Boolean. It's like you're either going up or you're going back down. So there's really going to be three things. First thing that's going to happen is you're going to say if I equals length of nums, return infinity. It takes infinity removals if something else 0. And the something is you didn't actually form a mountain array. You formed something that's like purely increasing. And that will only happen if increasing. The way I'm going to do this is actually increasing is greater than -1. Because what inc is going to be, it's not quite going to be a Boolean. It's going to be a Trullian. There's going to be 1, 0, and -1. 1 means it's increasing. 0 means you're currently at the top element. And -1 means it's decreasing. Because if you just had this be a Boolean, then you would say, okay, it's increasing, it's increasing, it's increasing. And then the moment you select X for the top element, let's say 6, then the rest of it is decreasing. But what if you like selected 1 as the top element and then you get to the end and you would say, okay, cool, it's decreasing, but you never actually decreased at all. You just reached the state where you want to start decreasing. So you need to have this kind of have 3 states rather than 2, which is a little sketchy because now we're getting into O of n squared times 3, and 3 million is like, should be fine, but I'm doing it recursively, so that might not actually be fine. But whatever. All right, well, still pretty slow, but maybe it'll be okay. So then the question is, how would you do this in better than O of n squared? Yeah. I guess like to get any element to be, like I think there's a way to get rid of X here. Because you could say for any element, say 6 or 5, in order to get here purely increasing, the cheapest way to do that is going to be the cheapest way. It's going to be some kind of longest increasing subsequence thing. Well, that'll kind of just be it though, right? Like I actually think I'm way overthinking this. It's just going to be longest increasing subsequence in one direction and longest decreasing subsequence in the other direction. That kind of makes sense. So you would say, what's the longest increasing subsequence up to here? And then that gets you the number of ways to Yeah, I think that's okay. All right, so fuck all this. This is all dunzos. I think so. I think you just you record what's the longest increasing subsequence up to any index, and then you say what's the longest decreasing subsequence from any index. And then once you have that, you would just go through every element and say what's the longest increasing subsequence up to here and longest decreasing subsequence from here. It's like the length of the array minus both of those put together, plus 1, because you'd be double counting the 5. So I'm going to test out the logic to see if that makes sense. LIS. Okay, how do you do longest increasing subsequence? For x in nums, do you have to do this logarithmically? Like, is this going to be like n log n? I kind of forget. I'm sure there's some fancy way to do it. Okay, yeah, it is n log n. Okay, I'm not crazy. How do I want to name these? I want to be like somewhat smart. F is forward, B is backwards. Okay, F and B are that, so this is now going to be called A. Here, every step of the way, I guess I can just say F dot append length of A. And actually, this is not going to have anything. So now F should represent like the longest increasing subsequence up to any given character. But it's not that simple. I think it just works anyway. I think it doesn't matter. The longest increasing subsequence up to the 1 is indeed 2, because it's like there's 2 things before this. The thing I need to be careful about is if I have some big array, like here, the longest increasing subsequence, like up to the 7, and the longest decreasing subsequence after the 7 are both going to include the 7. So what I want to do is make sure that I say like F at I and B at I plus 1. That way, like, it's like the longest increasing subsequence up to the 7, so 1 and 7, and then the longest decreasing subsequence after that, so that there's no overlap. So I never have to actually worry about whether I've counted 7 twice. Because like if I said ending at this point inclusive and starting at this point inclusive, I have to like account for the fact that I double counted 7. But for this 1, I don't account for that fact because the longest increasing subsequence doesn't include it. Longest decreasing subsequence, I think I can just kind of reverse it, right? I can kind of just say like, so this is now backwards. This is the longest decreasing subsequence. That seems pretty true. Cool, so I've made the forward and backward, and now it should be pretty simple. It should just be return. Do I want these to be F and B, or should they be like I and C for increasing? No, they should be F and B. F at I plus B at I plus 1. But then it's really not going to be these. Well, it is going to be these. It's going to be the maximum of that and minus that. So it's like the situation where you didn't have to remove anything. This will be the length of the array. And now I'm not quite done because there's one more thing I have to do. It's not just this. It's only this if F at I and B at I are both not 1. Yeah, because if F at I is 1, like here, and that's what this is doing, it's saying like, oh, we'll just take the 9. Then it's purely decreasing. And if B at I is 1, then it would be purely increasing. Like if you only took the 1, I guess is what that would mean. So I need a way to just kind of be like, I guess I'll just say length of A for now. If length of A doesn't equal 1, else negative infinity. I think it's not both of these are negative infinity. I think it's like, well, 1, 3, and 1, you don't have to delete anything. Yeah, the problem is here I do kind of want these to be 1. And I think there's a simple fix, which is just to make sure that at least one of these is greater than 1. Even that wouldn't always work. Like here, one of these would be greater than 1, but one of these would not be greater than 1. I think a really hacky solution is I could just append to forward and backward what the largest number of the longest increasing or decreasing subsequence is along with the length of it. And then I can just check if they're equal, then subtract that out. Yeah, I'm going to just do that. That seems fine. And then I just say F at I plus B at I at 0 for both of these minus F at I at 1 equals B at I at 1. Okay, and now I'm back to the like increasing decreasing problem, which I solved before, and I think with my new formulation of what to do here, it shouldn't be the end of the world. So if the maximum for both of them is the same, then you got to take one away. I think the advantage of having one side always be greater is that then I can say with certainty, if you're saying everything after a given pivot point, like this is going to have the peak, then you know that if that length is 1, then the whole thing is purely increasing. So if I get rid of that notion and it's more symmetrical like it is now, then I can't lean on that anymore to make sure that things won't be increasing, like purely increasing or purely decreasing. I think the way that I have this set up, both f at I at 0 and b at I at 0 have to be greater than 1. Because if either of them was 1, that means that including this current element, everything before and up to this is purely decreasing. So no matter what b at I at 0 is, the whole array is going to be purely decreasing. Yeah, that's what it is. That wasn't too bad. That was kind of a good one. I think I want to map a filter. I don't want to map range n minus 1. I want to map a filter on that. Because I want to filter out all this garbage, like this negative infinity. I don't want that. So I'll say lambda I, 1 not in this. That's like one thing. Oh, that's actually the only thing. I think that's kind of just fine. Yeah, okay, that still works. 1 not in that. Is there a better way to do that? Min is greater than 1 would be a lot shorter. Okay, that's fine. Is there any way to shorten this lambda I? This is about as short as it's gonna get. This is pretty good. Okay, it's gonna be a bunch of garbage and this. And it's gonna be defining f and b. F is gonna be something for x in nums, right? So map something nums. And then it's probably gonna be a list. Yeah, I'm gonna say A is nothing. Do this. A dot clear, do this. So F is going to be a bunch of stuff, and then in the end, it's going to be length of A at -1. That's like what we're ultimately adding. And then this thing always has to come true. So it's going to be some sort of take while. No. It's just going to be the bisect left thing. So IDX is that. Do I really care that much about a ternary operator, or do I want to mess with the ands and ors here? I'll mess with the ands and ors here. I'll at least do that because I feel like I'm not making this the most elegant thing ever. Yeah, that's fine. I mean, that's like weird, but... And then B is going to be really similar. And it's probably even just going to be like whatever I'm doing backwards because I just say B equals B : -1. So it's the exact same thing except reversed nums. And at the point where that's exactly the same thing, I could actually just say, oh my god, there's way too many fucking variables. I'm gonna go through and rename all these in a minute. But I'm gonna say f : equals, and this is A, bear with me, lambda array and stack. I'll say T for temp, it really doesn't matter. And what this is gonna do is it's gonna output this entire map. So the idea is you're saying, like I'm just consolidating both of these functions to the same thing. Let's see, that's f. I'll have one of these be, I don't know, g. G : equals f of an empty list and nums. And then I don't need a dot clear anymore because I'm like using just the input parameter, so it's fine. And then g or h is equal to f of an empty thing that's going to be the like longest increasing subsequence and nums backwards. I think that's slightly shorter than reversed, and then it's that backwards because that's like logically what I figured out. So that should be okay. List assignment out of range. It might be this. Yeah, it is this. So my logic was a little wonky. Oh, well, I just reversed these. I don't know why I reversed these. Function object is not subscriptable. I'm guessing I accidentally... Here I call f. Here I call f. Oh, well, I know the problem. The problem is that I like renamed a bunch of shit. So this is all just completely wrong now. So max heap that but now instead of F, it's G, and instead of B, it's H. Wow. That was an exercise in, That was an exercise in remembering variable names. I can't imagine a more confusing way to have named these. Well, no, I don't know. I mean, in retrospect, I landed on something kind of reasonable. I just like transitioned so violently between A, B, and C, and F and B to F, G, and H as the salient objects, which kind of implies that G and H are functions, even though they're objects. So, but whatever. That was a good one.